calculate the determinant of A, which is 3 by 3, which is 315, 102, 24, negative 3. So here we go. The determinant of A is equal to vertical bars 3, 1, 5, 1, 0, 2, 2, 4, negative 3. And underneath that, I'm just going to plus, minus, plus, minus, plus, minus, plus, minus, plus, draw my little checkerboard. And now I'm going to pick a row or a column with the most number of zeros. Or rather, you should. Which row or column do you want to expand along?
Row 2.
Row 2. Let's actually do a column, but that would be a similar choice. That would be fine. So I'm going to pick this column, which means my plus minus signs are going to be negative, positive, negative. So this is then equal to a negative 1 times a minor 2 by 2 plus 0 times a minor 2 by 2 minus 4 times its minor 2 by 2. So as we go through here, the minor for the cofactor 1, let's see here, duplicate, duplicate, duplicate. So I'm just going to do this for reference down here. Actually, let me make these all a different color. Style, blue, erase. So for the 1 cofactor, I'll kill that row and column. And that means that my minor is 1, 2, 2, negative 3. For 0, we don't have to do this. But just to illustrate it, the minor is 3, 5, 2, negative 3. And then for 4, the minor is 3, 5, 1, and 2. So let's see here. Well, that's hard to look at, dude. It's a little bit better. So those are the associated minors. That's where those numbers are coming from. And our result is negative 1 times the Twinkie, 1 times negative 3 minus 2 times 2, plus 0. I'm not even going to do that one because this is a 0 cofactor. Minus 4 times 3 times 2 minus 1 times 5. So watch your parentheses here. This is equal to negative 1, and this is negative 3 minus 4, plus 0, minus 4 times 6 minus 5, which is negative 1 times negative 7, minus 4 times 1, which is 7 minus 4, and the determinant is 3. And that's cofactor expansion for a 3 by 3. Let's see here. That wasn't too bad. That didn't take too long. It didn't even take that much paper. In fact, it took more paper because I was illustrating what I was doing as I was doing that expansion. So it doesn't have to take too long, but you do want to go slow enough that you don't make any silly mistakes. And people are going to make silly mistakes, like right back down here. People are just going to go fast, and they're going to call that an 8, or, 2 times 3 is 5, or something, ridiculous, just because you're doing a bunch of quick mathematics. that's relatively simple. So be careful there. We're going to do a 4x4, and then we're going to take a little break. Okay? So this is a little bit more exhausting. Let's see. I should probably name these examples. Was that my first example? Example 1, example 2, example 3, example 4. Find determinant A if A is equal to, what do I got here? Let's see. 1, 2, 3, 4, 0, 1, 2, 1, 2, 1, 0, 0, 1, 3, 0, 7, which is 4x4. So here we go. Plus, minus, plus, minus, minus, plus, minus, plus, plus, minus, plus, minus, minus, plus, minus, plus. Let's choose. So let me duplicate this. What do you think? Row or column?
Row 3.
Row 3. Let's do row 3. So here we go. Determinant of A is the determinant of 1, 2, 3, 4, 0, 1, 2, 1, 2, 1, 0, 0, 1, 3, 0, 7. And that's equal to a positive 2 times the minor determinant that goes with it, minus 1 times the minor determinant that goes with that, plus 0 minus 0. And so we don't care about these minors because they have 0 cofactors. So I'm not even going to bother writing those out. But, and here's the real problem, right? Duplicate, duplicate, change their color scheme. Purple. When we cross out the row or column containing that 2, our minor determinant isn't 2 by 2. It's 3 by 3. So maybe you can work out what that means for yourself. I'll explain it if you can't. As soon as we're done here, we'll move to our next minor determinant, which is for the 1. We'll cross out the row and column containing 1. And we get 1, 3, 4, 0, 2, 1, 1, 0, 7. So these minors are 3 by 3, and we need to calculate them using cofactor expansion. which means that we started with the 4x4, but now we have to do 2 3x3s. So had we not picked a row or column with the most amount of zeros there, we would have had to do 4 3x3s, which would have been this example 4 times, right? So it's really, really important that you, when possible, choose the row or column with the most number of zeros. Okay, so let's continue. So continuing. Let me move this over. This is equal to 2 times. So we have to expand here. Let's do a plus minus plus checkerboard that's 3x3, plus minus plus minus plus minus plus minus plus. And for our first determinant, you need to pick a row or a column. So what do you want to do? Row 3, row 3. Let's do row 3. So if we expand along row 3, we're going to have to use that plus minus plus combination. So this is going to be positive 3 times the minor 3, 4, 2, 1 minus 1. Oops, sorry, I'm moving on to the next one. Sorry, I'm not even done yet. Expanding here, we have a negative 0 times the minor 2, 4, 1, 1 plus 7 times the minor 2, 3, 1, 2 minus 1, and we need to expand again. I'll just go across that bottom row again, make it easy. We have zeros there. So this will be a positive 1 times the minor 3, 4, 2, 1 minus 0 times the minor 1, 4, 0, 1 plus 7 times the minor 1, 3, 0, 2. So I didn't really have room to annotate all of that. Hopefully you're following this. And we got to go nice and slow here. This is 2 times 3 times this Twinkie. 3 times 1 minus 2 times 4 is 3 minus 8. Minus 0, so I'm not worried about that one. This one had the 0 coefficient. We're happy about that. And then plus 7 times the Twinkie product, 4 minus 3. Minus 1 times the Twinkie product, 3 minus 8. Minus 0 plus 7 times the Twinkie product, 2 minus 0. And this is 2 times the quantity 3 times negative 5 plus 7 times 1 minus the quantity negative 5 plus 7 times 2, which is 2 times negative 15 plus 7 minus negative 5 plus 14, which is 2 times negative 8 minus 9, which is negative 16 minus 9 more, which is negative 25, and that's the value of this determinant. So it starts out pretty slow, but it starts to pick up speed eventually.